Fine. So as I mentioned, so we will take up these four experiments. So you can observe first we'll be writing a program to connect two nodes with the point-to-point link, which has a unique interface and analyze the, what, analyze the network performance using UDP client server. So students, before I will take you to the program directly. So what I'll be doing in the sense, so I'll take up this problem statement. Okay, so what I am going to do in the sense, so even in the similar way, even you supposed to understand. So here you here you're writing a program for what? So far you need to create a network. Okay, I repeat, you need to create a network which has how many nodes? Which has a two nodes. I repeat, which has a two nodes. Then you need to connect them. That's what you can also in this similar way you can also understand. You need to create two nodes. Then you need to connect them, right? You need to connect them using a using point to point link. What is this point to point link? We will see. Using point to point link, you need to connect them. Once after you connected them, I repeat, once after you connected them, then later you need to provide a interface. And I repeat, so you need to provide a interface. So then, so these are the three major, very important steps, my dear students. So in any experiment for that matter, you need to what? So you need to provide a interface. Once after you provide the interface, then later apply the application. These steps are common for all the experiments. Apply the application, then apply the protocol. So these things are very common, right? So for this, you will be writing a program in the NS3. So even for your information, so here, what kind of programming language you'll be using in the sense, it is a very, quite common thing. It is C++ program, C++ language we'll be using to generate a program right here. Right, so for suppose right now, as I have mentioned, so these are the 5 steps are very important. So then what are we doing? So you need to create the nodes. Even I'll remove the two also. So you need to create the nodes, then connect them. Connecting them is very important. Connect them. Then using what is also I can remove it up. These are the generalized 5 steps. Create the nodes, connect them, then provide the interface interface, apply the application, apply the protocol. So then, so observe the results. What are the results you will be observing? So and what results you will have to fetch? That's the results part, output part, right? Now coming to the first experiment. So I repeat, in the first experiment, what are I going to do? So even for these 5 steps, find out from the first experiment. First experiment says here what I am writing, create the nodes. How many nodes you want to create? So based on the first experiment, they are mentioning that you need to create two nodes. So you'll have to create, see, you want to create two nodes. Then connect them by using what? So based on the first experiment, they says that connect them by using a point to point. Then apply the interface, and what application they are expecting? They are expecting a client server application. Is it not? They are expecting a client server application. And what protocol they want you to apply? It is the UDP, right? I hope so. You have a simple difference between the UDP and the TCP. You know that. So TCP is a connection oriented service where you requires the connection establishment before the data communication can begin. Whereas in case of UDP, it doesn't require any connection establishment because it is a connection less communication, connection less service, right? So that's how. So for these 5 steps, find out the answers from the given program statement. Even when it comes to the interface, what exactly this interface in the sense, building a what we say, the communication interface. Even once after they are connected, remember, even after they are connected, they will not be communicated until unless interface is built. So in our all our examples, we will be using a simple interface mechanism, which is IPv4 interface. We'll be using IPv4 interface mechanism by providing the respective, IP address and the port numbers to the respective nodes, right? So we'll be providing the based on the mask value. So that's how. So for these 5 questions, find out the answers from the given program statement. So once after you know these 5 statements, then only you can, we can proceed further. For that purpose, So for as a waiver I say that. So before I will take you directly to the a program. So first you're supposed to understand the design part or the analysis part. Then only you can understand the what program. So with respect to that, you can observe. So I have a simple slides right here. So this is what your first experiment. So where exactly what are we doing? In the sense, first we are creating a first we have to what create two nodes. Is it not the first step which I have shown earlier? See the step one, which is create the nodes. How many nodes I have to create? Two nodes. So in that connection itself, where I am creating two nodes, which I may be calling as node 0 and node 1, for which I is supposed to make use of node container. I repeat, so one of the NS3 package, which is node container. Remember, my dear students, as I have mentioned, this these five steps is quite common for all the experiments. So whenever you say that you are creating a nodes, I repeat, you are say that you are creating a nodes in the sense everywhere you'll be using the same package, same a library of NS3 itself, which is node container, in which where n is caps, c caps, that's for sure is a case sensitive. So n caps, c caps. So how many nodes you are creating? You may be creating two or four or n number of nodes. Whereas based on current example of current case study, we are going to create two nodes by using a node container. Once after the two nodes are created, then what is the next step? Well, the next step is what? Connecting them. So obviously by using what you would like to connect, it is the point to point. So that's what the second next step. So that's what next step. So where you'll be first creating a point to point link for your information, students. Whenever you say you're creating a link, whenever you are creating a link means whenever you are creating a link means it is just like a path. Basically, whenever you say it as okay, create a road between Bangalore to Mumbai. If you say that create a road between Bangalore to Mumbai, you must also mention what is the width of that road. So basically you measure that width of the road based on number of lanes in a road. With respect to road, this here also, if you are trying to create a link, in the sense that link should have the its own attributes. Those are what we call it as link attributes, and those attributes here we are considering, which is nothing else than the bandwidth and the delay. What is that bandwidth? In the sense which defines how much data can be transferred at a time, which is, you may also call it as data rate. With respect to digital transmission, you may also call it as data rate. How many bits can be transferred per second? In this example, I am considering as 5 megabits per second. Is it a constraint? Never. If you want to vary, you can vary that bandwidth and observe the results. Second thing is that a delay, which is 2 milliseconds. What is the delay? In the sense, again, let me compare with respect to your road example itself. What did I said? Bandwidth of the link is the same as the number of lanes in your road. On your road also, if you say that 3 lane road, in the sense three cars can move at a time. When the three cars are moving at a time in a road, so definitely there should be a gap between the current car to the next cars. If there is no gap, in the sense, what will happen? Accidents will happen. Here also it is, you need to define the delay, which is nothing else than the gap between the data transmission. So with respect to your, you can analyze, assume and understand with respect to cars on the road, or it can be here, it is a data, right? It's just like a gap which you are leaving between the data, right? So these are the two attributes which you're supposed to define while defining the any point to point link, right? So it need not be point to point link. For any link for that matter, when you are defining a link, you must define these two attributes, which we call as link attributes. You may also call it as channel attribute, right? The data rate and the delay. That's how you will be creating a link and then connecting those nodes by using a, I repeat, connecting those two nodes by using a net device container. So I repeat, so we are done with the second step. What is the second step? First create the point to point link. First create the point to point link. Then by using that link, connect those two nodes, right? That's what we did. So we created one link, and by using that link, we connected those two nodes by using a net device container. So that's what the step two. Then moving to the step 3. What is that step 3? What we said, it is what? Providing the interface. When you say that providing the interface, so obviously, so as I mentioned, we'll be providing based on the IPv4 interface container. So I repeat, my dear, whatever I'm showing at the top, so these node container, net device container, IPv4 interface container, these are common packages which are available in the NS3. Okay, so which we'll be making use of them to in our experiment. Okay, so those are the packages. So those are case sensitive as well. You are allowed to use in the similar fashion. Now, once after when we say that we are going to use this IPv4 interface container in the sense, it is you need to mention, you need to provide the IPs to the node 0 and node 1. When you'll be providing the IPs to the node 0 and node 1, it is however, so IP is one of the addressing. I repeat, IP is one of the addressing. There are the other addressing mechanisms like MAC addresses. So you have, so even the next you'll be knowing about the port numbers, which is port address. So basically here we are assigning the IP address based on the IPv4 interface. Even you can also think of IPv6 interface container also, where the address which is supposed to assign, which is of 128 bits. Whereas here, as it is IPv4, we are assigning only 32-bit addresses. And when you will be assigning any address, when you'll be assigning any address, basically what happens in the sense, so here we have taken an example that for the node 0 we have assigned as 10111, for node 2 that's a node 1 we have assigned as 10112. So is it a compulsory you were supposed to assign in the similar fashion? In the sense, never. You can make use of, you can assign any address, but based on that address the respective mask which is supposed to provide in the relative manner. That's it. So there is no constraint that you have to use in this fashion itself. Okay, so that's what the addressing. Once you assign the address, that's what, once you assign the address by using what, by using the IPv4 interface. So that's where we are end with the, we are done with the step 3. That's what, providing the interface. Next we will be entering to the providing the application. What application are here? It is that client server, and what protocol? It is the UDP. Based on this itself, we are going to the next step. Even for your information, what is this client server? Basically speaking, so how this client server varies with respect to the communication actual working mode. In the sense, client is the one which is the client is the person who is asking a question. Server is the person who is answering back. I repeat, client is a person who is asking a question in the means of request, whereas server is a person who will be answering back in the means of response. So client and server will be communicating, or communication between the client and server, it is in the means of request and responses. Until the client request, server will not, is not going to answer anything. So in that means, so when you are creating the two nodes, which is client node and the server node, so definitely you will have to create the server first before you create the client. Because if there is a person who can answer, then only the person, anybody can ask him. If you create a client first, what happens in the sense, even after there is a person to ask a question, but there is nobody to answer back. So in that connection, first logically create the server first, who is ready to take the request and provide in responses. Later you create a clients for requesting or questioning. So okay, so in that means first we'll be creating a server, then we'll be creating a client and those connection itself. So you can observe, as I mentioned, the fourth step where we'll be creating the application. So for that itself, we'll be using a application container. I repeat, for creating the applications, we'll be using a application container. What application is this? It is a UDP server application. So only we are imposing the UDP echo server, which is again one of the package which is available in the NS3 UDP echo server. We are imposing the UDP echo server in the node 1. We are imposing UDP echo server on the node 1. So what is happening in the sense, we are making node 1 to be a server node. Later we'll be making the node 0 as client node. But when you make the node 1 as a server node, very important thing here is that, so when you are making a node 1 as a server, you must also define the port number, because in the previous step we already defined the IP address for those nodes. Now it is, you need to define the port number. What is this port number in the sense, my dear students? So in a basically for a server, there may be n number of clients will be requesting the different services from the server. So server should have the classification between the process to the process which will be running in the server in order to have the difference and response back to the same client. As an example, per suppose now if I am teaching, if 10 of you may be asking the different questions to me, in the sense the answers when I am giving you back in the for the person A who is asking me the question, that answer I have to tell back to the person A itself, not to the person B or person C. And so whenever, as I mentioned, A, B, C, D are the four people who are asking me the question. At a time in my mind, if I am the server, in my mind, at a time, four different process has to run. So example, so my mind may be thinking about this network lab itself. Or my mind may be thinking about my personal life, or my mind may be thinking about some professional, or my mind may be thinking about some societal. Right now, you people can ask me a question related to this CN itself. That's what CN lab itself. So even though in my mind multiple processes are working, but which process you can reach me out, that differentiation you can make me out in the, or you can make out in the port number, because you can reach me by using a IP address. But in me, there are four processes. Among those four processes, you can reach me to the exact CN process by using a port number. So it is so it is the importance of your port number. Even if at all, if I have to give the one more example, like apartments. So in an apartment, so a standalone building where we may be having a single home in it. So it's a single person, single owner in it. When it comes to the apartment, there will be hundreds and thousands of houses which is the flats in that apartment. So thousands of owners are there. When the letter has to reach to the respective person in the sense, so in a Google Map or wherever you can reach out, you cannot identify the flat based on the flat number in the Google or in any maps or any addressing, but you can reach out to the apartment by using the apartment address, which is just like IP address. Then inside the apartment there are the respective flat number 403. So that is what port number. So inside a server, as multiple processes may be happening, every specific process number or process number can be identified by using this port number. So it is very important to define the port number while defining this server. It is not only server definition. So right, so once after server is defined at the node 1 by using a application container and what protocol you are imposing, it is a UDP. Then define the client also by using the same application container. Now it is a UDP echo client instead of UDP echo server, where we are imposing on the node 0. So now what happens, node 0 has become client, node 1 has become server. Now, so for the so as I mentioned, it is the client who has to send a request to the server. It is the person who has to ask a question where the person will be responding back with the answer. So now the client is sending a packet. How many packets it is sending? Only one packet. What is the size of that packet? It is 1024 bytes, and it is sending to the destination. Which it is destination? I hope you remembered in one of the previous step when we assigned the IP addresses. We assigned 10111 as the IP address to the node 0 and 10112 as the IP address to the server. So on which port? So as here, as I mentioned in the previous step, so here server has to define the IP, port number. We as in our case study, we assumed that port number at the server is 9. So we are sending, client is sending a packet to the, how many packets? One packet of size 1024 bytes to the destination. What is the destination? It is 10112 is the destination at the port number 9. Is it 9 is compulsory? It is 9 is not, my dear. Who has defined this port number 9? In the sense, this is the port number of the server, which is defined by the server only, which is letting to know to all the clients. Okay, it is this port number of the server is not defined by client, it is defined by the server itself, like that. So we are done with the 4 steps, sorry, 5 steps: creating a 2 nodes, connecting them by using point to point link, and providing the interface, which is IPv4 interface, applying the application, and then which protocol we imposed here, it is the UDP, right? So finally, it will be like this, where the UDP client will be node 0 with the IP address is 10.1.1.1, and UDP server is node 1 with the IP address 10.1.1.2, where client will be sending a packet, which is UDP packet, and server will be responding back with the response is also UDP packets itself, right? So this is what your complete first experiment, theoretical analysis. Students, did you understand this?
Yes, sir.
Yes, sir.
Any queries until here?
No, sir.
Shall we continue?
Yes, sir.
Yeah. So as a part of continuation part, as however we are going to have a as in the problem statement here itself you have said, so we have to generate a NS3 program for this. See, till now I did not till now we have only discussed about the analysis part. Okay, so how exactly we have to carry out. Now let us go to the program. Hope my Ubuntu screen is visible to you all.
Yes, sir.
Yeah, by the time it wake up. So let me show you something, my dear. So once after you install, this whatever I am showing you right now through the PPT is this is very very important. So because once after you have your NS3 in your system, so basically, so this is a folder which we called as NS3 all in one. So the version may be 3.27 or 3.33, no matter, so it just a version varies. So inside that there will be a different folders. So which folder is supposed to choose for programming, in the sense it is ns3.3 through ns3.33. So inside this ns33, so there will be a source folder, scratch folder, there will be other folders also, among which, remember, you will have to choose this scratch. I repeat, you will have to choose this scratch folder for what, in the sense, for generating a program. What are the kind of programs here I'm talking about? All these programs you're supposed to write, create in the scratch folder. And I mentioned that what kind of programs, it is C++ programs. So whatever the files you will be creating inside the scratch folder should be a .cc. I repeat, it should be .cc. Any program you create. So I repeat, you can also go with the Python program also. No issues, because in the NS3 you can also run the Python programs. But in our case study, we are taking up the C++. In further cases, we are going to see about the Python also. Okay, so remember, any source file or not source file, you can, yeah, you can say that. So program, source program, we're supposed to create, in the sense it is in the scratch folder only, not anywhere else. So you have ns3.33 inside that ns3. So inside that scratch, so inside the scratch folder only you are supposed to create, not anywhere else. So as an example, I hope I have displayed this Ubuntu screen. It is visible to you all. If not visible, you can also let me know. So you can see this NS3.33, which I have moved this icon or the folder icon. You can observe NS33. Is it visible, students? Ubuntu screen?
Yes, sir.
Yes, sir.
Yeah, yeah. When you go inside this NS33, as I mentioned, there will be different folders. So you don't have to touch any folder. Just go to this NS33. So inside the NS33, as I mentioned, there will be different folders. So among this, you have to go to the scratch folder. When you go to the scratch folder, this is where you're supposed to create the source files like this. I repeat, this is where you're supposed to create the source files like this, which is any source file with the .cc. These are the executable programs. Okay, so that is what the creation process. Then later, when it comes to the execution, so how to execute? I hope different kinds of programs will be executed you I hope you and Unity did the execution of the C programs or C++ programs from the terminal of your Ubuntu, or it can be command prompt of your Windows. So right now, so for the execution, you're not supposed to be in the scratch itself. You need to go back to the NS33. I repeat, you need to go back to the NS33. That is where you'll be running the command. It is /var. I'll show you, no worries. So right now, so let me take you to the program. So for suppose, as I mentioned, what exactly we have to do? So first get into the terminal. First get into the terminal. So inside in the terminal, so as the NS33 is in there in the desktop, even before that get into the sudo mode. So how to get into the sudo mode? Sudo space su, provide the sudo password, which is root password. Then so hope the text is visible.
Yes,
So
sir.
get into the desktop, then in the desktop NS33, NS all-in-one 33, then NS33. Again, inside this, get into the scratch. This is where you can create a file, which is by using as usual gedit. I'll say the gedit 1.cc. Gedit 1.cc is already 1.cc is already available, which is the program which we have seen till now. So I just opened that as 1.cc. I'm just opening that program. So this is the program whatever we discussed till now, my dear students. So for your information, there are a lot of header files whatever we'll be using. Here we may also call it as header files or packages, and also where these are available. Okay, for your information, what did I said? So inside the NS33, I told you you are supposed to get into the scratch folder for generating any source program. And similarly, these header files will be available in the source folder. Okay, so these are the header files. Based on the requirement, we'll be using those header files which is inside the source folder. Now coming back to the program, so these are the header files where we'll be using. For your information, for any NS3 program, this core module.h is compulsory. Core module.h is compulsory. Then we need a network module. Why do we need a network module? In the sense, as we are creating a network of two nodes. I hope you remembered from our previous explanation. So we are creating a network of two nodes. Then we are also connecting them by using point-to-point link. So we need a point-to-point module also. And we are providing the IPv4 interfacing, for which we need a internet module also. We are applying the application which is UDP and UDP server and UDP client, which is where we are applying the application. So which requires the application module also. After doing everything, we want to observe the results in the network animator. I repeat, after doing all the simulation, we want to observe the results in the network animator, for which you'll be using this. If you don't want to if you don't want any network animator, if you don't want to see any results in the network animator, then this is you don't require this. Okay. So next, as usual, so as it is a C++ where you are defining the namespace, then later you are writing, you are creating one log file. You are creating one log file as a first sample. You can write anything. So then, so this is where actual steps will begin, my dear students. So whatever the steps we have taught, so the same steps, I hope you can also make out that connectivity. What did I said? The first step was what? We're creating the two nodes. For creating a two nodes, what did I told you? We'll be using what? Node container. So you can observe we are using a node container to create a two nodes. So we are using node container is a package. This nodes is a variable. So nodes dot create. How many nodes you want to create? Just two nodes. So we are done with the step one. Students, does the program is visible to you all? Are you following?
Yes, sir.
Yes, sir.
Yeah. So the step one was just to create two nodes. So by using what? By using node container. Node container is a package. This n caps, c caps must be there. Whereas this nodes is a variable. However you want to define, you can define. By using that itself, you are just using create function. So whereas when you are calling the create function, the c must be caps and you are passing the parameter as two. So create function which creates the nodes. How many nodes? It's just a two nodes based on this case study. You can also, when you are creating multiple nodes, you can also extend any number. So that's where creating a two nodes is a first step. Step one is done. What is step two then? What is step two then? So what was step two? Can you guys recollect?
Point to point connection.
Yes, you need to first create the point-to-point link. So it is as same as two isolated nodes you have created in this step. Now you need to create one link that using that link you need to connect them. Now while creating that link, which link it is a point-to-point link for which we'll be using a point-to-point helper. We'll be using a point-to-point helper. This point-to-point is a variable again. So by using this, you can say the variable or it is kind of object to the class point-to-point helper. So as I have mentioned while explaining theory itself, we are defining the two attributes. One is the data rate and the delay. Data rate here I have defined as 5 Mbps. You can also vary it. Again, delay 2 milliseconds. You can also vary. So like this, by defining these two attributes, which is data rate and the delay, first you have to create the point-to-point link. Then by using that point-to-point link, you have to install between the nodes. So whatever the nodes you have created, between those two nodes, you have to install that point-to-point link, so which makes a network. So once after the two nodes are connected, which is making it as a network. So we are done with the step 2. In the step 2, what did we do? So where we created a point to point link by setting the two attributes, and by using this point to point link, by using that point to point link we connected those two nodes, or but that point to point link is being installed between the nodes. That point to point link is being installed between the nodes, which is making a network for which we are using a net device container. So we are done with the step 2. What was step 3? It was interface, applying the interface, for which interface, as we mentioned, we will be using the IPv4 itself. So before you can apply the interface, so obviously it's completely just like a stack, my dear. It is one above the other. So where we are using the internet stack helper, so that stack is being installed on the nodes, and the two nodes. So when there are two nodes, so on both the nodes you need a stack. It is at the center side and also it is at the receiver side. So two stacks we require, right? So the IP stack is being installed on the two nodes. Then later we are setting the base address. See, base address is just like a starting address. Example, per suppose if you are just like your SRN, when you talk about your SRN maybe which will be having your university code, your department code and year code is common, whereas your students numbers last three digits will be varying, right? So when you take up your SRN, you'll only last three digits will be varying, which is just like that is what your SRN for that matter. Whereas here in the networking we call it as net ID and host ID. You have to, by assuming or by considering the respect to net ID and host ID, you will have to set the base address. So based on that itself, mask will be considered. Remember, my dear, so as we have set as 10 1 1, it is 255 255 255. If it is 10 0 0, then only 255 0 0. I repeat, as we have set as 10 1 1, so the mask is 255 255 255. If you initialize the base address as 10 0 0 0, then 255 255 255. Is it only 10 always? No, not required. You can also change as 100, 109, and what 615 dot 150. Anything you may consider. Anything you may consider, but very importantly, based on the net address and the host address, that is very important. Based on net address and host address itself, or net ID and host ID of your IP address, based on that itself you will have to set the mask. So these two should be relative. Either based on this you have to set this, or based on this you have to set this. Okay, so anything is okay based on the that should be relative, that is for sure. Next is that this zero. So what I told you about till here. What about this? Can you make out this as any number? In the sense, do not make any other number, keep it as zero itself, because it is what a base address, as I have quoted with respect to your SRN, where I hope your SRN may be having 6 to 7 digits. So okay, in that, as I mentioned, your university number will be there, university code will be there, your year will be there, your department code will be there, followed by 3 digits is only your student numbers. When it in that 000 is the starting address, which will not be there for anybody. So as your SRNs will start from 001 002 like that. So that is what you call it as base address, initial address, starting address. So in that connectivity, don't set this. So you can, if you want to set 109 0 250 also 0. Okay, no issue. Whereas on that, in that connection, it is also you have to make it as zeros. Nothing but nothing to worry. So first node would be what? So based on this base address, first node would be 109.0.0.1. 2, 3, 4, 5, 6, like it goes like that, right? So in even in turn 109.0.0.1 would be the gateway address. That is, that concept we'll discuss later. So what I'm trying to convey from that from the line in the sense, my dear, you can set any IP address right here. There is no constraint what you see here, but while this IP address and this mask value should be relative, there should be in the same relation. There should not be any conflict between that. Okay. So that's what, where we are done with the step 3, where we have, as I provided the interface. Then what would be the step 4? I hope you remembered. What is the step 4?
Client server, the
Yes,
application.
applying the, yes, applying the application. In that, first we'll be applying the what, so client server first will be, as we mentioned, first we'll be defining the server, then we'll be defining the client. So this is where we are defining the server. So as I mentioned, first, before how are we going to define the server? In the sense, it is by using UDP echo server helper. How are we going to define the client? In the sense, UDP echo client helper. Okay, so UDP echo server helper, UDP echo client helper, because it is a UDP server. Okay, sorry, UDP protocol that we are going to use, right? And what is this 9? In the sense, as I have quoted in the theoretical also, it is the port number. If I don't want to use 9, okay. If I have to use 19, okay. But port, defining the port number is important. But what number you will use is not a constraint. But you are defining that port number is very, very important. Once after a server is been initialized, then that server itself is installed in any one of the nodes. How many nodes you created? We created the 2 nodes. When you created 2 nodes, it will be 0 and 1. So we are imposing that server in the node 1. That's what install echo server install in the get of 1. So in that we are installing the in that IP address, which is node 1 IP address, we are installing the server. So I repeat here, 9, 19, 80, basically try to avoid the public port numbers like 80s, 27, 25 and all. So you can use any number, but remember, so defining the port number is must. So here you can say it as 19 or 9 or 8 or 6, whatever. Okay, or 60 or 35, any number for that matter. But defining the port number is must. Then when exactly the server has to start and when exactly server has to stop. In our case study, we have taken as at 1 second server has to start and 10 seconds server has to stop. That's it. So we are done with the initializing the server. Now when it comes to the initializing the client, so as usual, we made use of UDP echo server helper for server. We are using UDP client helper for client. So this is very, very important. So okay, you are creating this client for which server? Okay, you are creating this client for which server? In the sense, that is where we are going to use this interface between the server. Which server? It is a node 1. Okay, because in the node 1 only you have initialized the server. So it is that server and the respective port number. See, you may reach to this server by using this address. Okay, by using this address, which is IP address of the node 1, you may reach to the server. What did it tell about the port number? You may reach me, but you can only ask me question related to the CN. But in my mind, multiple things are working at a time. In my mind, maybe thinking about my personal, my official, my XYZ, all that. But you don't have access to reach to all those. You can reach me only through this networks. So for that port number itself, you have defined here, right? The same number you have to replicate. Here, if you say 19, here also it should be 19. If you say here is 90, here also it should be 90. Because yes, you are, when you will be creating a client for which server? For this server who can only reach to this process. Okay, so this port number and this port number must be same. Very, very importantly. Right. So likewise, the client is created for the respective server and which has access to the respective port number. Now you can define how many packets you want to send. You want to send only 1 packet. Okay. If you want to send 10 packets, you just make it as 10. Okay. What is the size of each packet? It is 1024 bytes. Okay. If you want to change. But basically we defaultly we set as 1024. That's it. Then what is the interval between every packet? It is 1 second. Okay. If you want to change it as, you can change as 2 seconds or 0.5 seconds, anything for that matter. Okay, this is only the interval between the packets. Next is, so that client, whatever you have defined the client, whatever the client you have defined, that we are installing on the node 0. So based on this concept, I hope you got this point. So node 1 is acting as a server, node 0 is acting as a client, and when the client has to start and when the client has to stop. So you see here, client is starting at 2 seconds, client is ending at the 10 seconds, where the server was started at 1 second and it has ended at 10 seconds. So that's how you can, client is also defined. And I'll talk about these three lines later. I repeat, I'll talk about these three lines later. Now, as usual, you will be starting the simulation, running it, destroying it. So that's what the end of your program related to that program, problem statement. Yes, guys, did you understand this? Before I show you the
Yes, sir.
results. Now, when it comes to the
Yes, sir.
results part, yeah, so I'll just close this. I don't save this, so I'll just close this. So as I have, as we are done with this, so as I mentioned in the PPT itself, so here I have shown you. So even if you're not written down also, you please make it down. So this is what the executable command. But as I mentioned, in the scratch folder, you have created the programs. But for execution, you must come back to the NS33. I repeat, for execution, you must come back to the NS33, not in the scratch folder. So how do we do that? See, I repeat, my dear. So in which folder are you right now? In this, it is very important. You are in the scratch folder right now. You are in the scratch folder right now. So I need to go back. So how to go back? Obviously, I hope you know, right? CD space double dot. Now this is where I need to run the command dot slash waf space hyphen run space. Where is the program? It is a scratch folder. Inside that scratch folder, what is the name of the program I had given? It is just a one. Basically, it is one.cc, right? But do not give us .cc because we don't need any respective extension of file, whether it can be .cc or .py, anything. We just need a program name. It is one. So I repeat, what is the execution command? It is dot slash waf hyphen run space scratch slash program name, which is one. And where am I running? I'm running inside the NS33. Where you created the program, you created the program inside the scratch. Hope you have that, hope all of you have observing that. So execution command here it is dot slash waf hyphen run scratch slash program name, whatever the program name. So you are not bothered, you don't have to bother about the extension. It can be .cc or .py. It can be Python file or .cc file, right? So it will take a couple of seconds to complete the execution. Students, are you understanding?
Yes, sir.
Yes, sir.
Meantime, if anybody would like to ask anything. So as I quoted at the beginning itself, understanding this experiment is so important. So because another three programs, whatever I have listed for today, so those will be completely depending on this explanation, this program. So if you understand this program completely, and it's not only about the understanding about the program, so you can understand the program only if you understand the concept. So once you understand the concept, then you can only understand the program so easily, right? So I'll just see it again.
all these commands are run in terminal only, right? No?
Yeah, you will be running, you will be working from the terminal itself. Yeah, building is
Okay.
started. So you can observe. So WAF is entering the directory, which directory? This to the build directory. So once it entered to the build directory, then only you can say that, okay, compilation is started, execution is started. Now you can see build is finished. Build finished successfully, and it has taken 22.477 seconds to complete this building of this program. Building is all about your executions, right? So yeah. Okay, just a minute. Interface. Even in between, so when it is happening, so let me tell you one more point which is very important for you guys. So basically, as I have quoted earlier itself, all your programs you will have to create in the scratch folder. But remember, so you may have any number of programs inside your scratch folder. Example, I'm running in the one dot my current program is 1.cc. If there are any errors in the 1.cc, definitely I will not get any output for the 1.cc. It will throw you those errors. First, suppose if there is one more program file which is 551.c or 66.cc, even if there is some error inside this 66.cc, but your current program is 1.cc, even then you will not get the output. Remember, keep that in mind. I repeat, very simple. When as you are, you are running that command out of your scratch folder. You are running the WAF inside the NS3. So whatever is there in the scratch folder, so it expects that all the programs are executable programs only. So if any program inside the scratch folder is having any error, so definitely you will not get the output. You have to see that all the programs inside the scratch folder are complete, not incomplete, doesn't have any errors. All those things you have to make out. So only better you can keep only your current program inside the scratch folder instead of like this. So if even if it has couple of programs, it is you need to make sure that no program has any error inside those programs, right? So now, so I hope you all can see the results right here. This is only the output, my dear students. So there is some warning with respect to the animation file, no issues. So I will come to that point later. So see, the build is completed. So there are the warnings with respect to animator interface. So I'll show you that later. So now you see, this is what the output. I hope you can observe whatever I have highlighted here. What is the under I have highlighted here in the sense? Basically, see at what time based on your program also, I hope you remembered what was there in your program when exactly the client has started. It is at the 2 seconds. how many packets the client has to send. You can observe right here. Client is started at 2 seconds. How many packets it sent? Only one packet. What is the size of that? 1024. What is the server port number? It is a 9. So the same story which is written here. If you observe in the terminal, can you observe? See, at 2 seconds, client has sent 1024 bytes to the 10112, which is a server's IP at the port number 9. At 2.00369 seconds, server has received that. So total time taken from client to the server is 0.00369 seconds. Server has received from 10111, which is a client at the port number 49153. Right? So after that, server is responding back with the response, which is at the 2.00369 seconds. So to whom? To the same client at the same port number. And finally, client has received at 2.00737 from the same server at the same port. So here, if you observe, so total time taken from client to the server is 0.00369 seconds. I repeat, 0.00369 seconds, and round turnaround time, which is round trip time, you can also call it as, from client to the server, then back to the server, it is total time is 0.00737 seconds. And in our example, we have taken only one packet, right? Is it not? We have said as only one packet. If I make it as four packets, what is the difference you can find? In a sense, nothing difference. Same thing will be repeated for 4 times. Same story will be repeated for 4 times, because 4 packets has to go and come back, right? So for those packets, so packet 1 has to go to the server, again it has to come back. So packet 2 has to go back, go to the server again. For that, it has to get the response. Packet 3 and packet 4, the same story will repeat. So whatever you saw this here for 4, whatever you saw for 1 packet, the same thing you see here for 4 packets. That's it. You can see, you can observe at 2 seconds, client has sent and received that response at so and so time for the packet 1. Again packet 2, right? Packet 3, here is that packet 3, and finally packet 4. Here, what you want to observe right now, in the sense, you can observe, I hope you are observing this results. You can see this at 2.00737 seconds itself. Client has received the response for the first packet, but client is not sending the next packet until 3 seconds. I repeat, at 2.00737 seconds itself, client has received the response for the first packet, but client is not sending the next packet until 3 seconds. Similarly, client has received the response for the second packet at 3.00737 seconds itself, but it is not sending the next packet until 4 seconds. Why? Why is this? In the sense, because you have set the interval as 1 second. I repeat, it is you are the one who has set the interval as 1 second. If you don't want this, 1 second, you can observe this. Instead of this 1 second, if you set as 0.5, if you set as 0.5, now you observe. So what happens? See, there's the interval after my first packet when I supposed to send the next packet. That is what all about. That's what all about the interval, right? See, now you see after 2.737 seconds, first it has received the response for the first packet. Next packet it is sending at the 2.5 seconds. Again, next packet it is sending at the 3 seconds. Next packet is sending at the 3.5 seconds. So that's what is the interval of next packet, right? Hope you are getting. If you make it as 0, what happens? So I'm changing the parameters and I'm showing the different cases. Similarly, you can work out for any case, my dear. Okay, hope you are observing. Now, did I save it? Yeah, save it. Now I made it as 0. So if you observe this, so I made the interval as 0. Now if I execute, what would be the output? Can you guess out? So where interval between the packets is zeros. As I made the interval between the packets is 0, so all the 4 packets will be pushed out at a time. You can observe all the 4 packets will be pushed out at a time. See, at 2 seconds, 4 packets had went out. Understand this, because you did not give any interval between the packets at the client. So all the 4 packets are sent out. But does all the 4 packets are received at the receiver? No, not all the packets have received at the server at the same time. It has an interval because of the congestion itself. Obviously, because of that, there should be some delay among which, right? So this is how you will have to keep changing the parameters and keep observing the results. So before we go further, last one change, let me show you one more. See, like this, you are allowed to keep on changing the parameters and observing the results, my dear students. So I'll just make it as one packet itself and interval as one itself. So now, as we have already executed this, again, if I execute, now you observe this. The total time taken for this, it is obviously so for the turnaround time it is 7,00737. When the you can observe when the bandwidth was data rate was 5 Mbps. Can you observe this 5 Mbps? If I make this instead of 5, if I make it as 10 Mbps, then you see what is the time taken. What would be the time taken? Will it be the same or increased or decreased? So when the band data rate was 5 Mbps, the total time taken was say 2.7300737. But now when I made that bandwidth as 10 Mbps, you can observe total time taken was only 00569, where the time is reduced because width you increase, width of the road is increased. Instead of three vehicles, 5 vehicles can move at a time. So definitely time will be reduced. So it is something like this. So bandwidth of the when the data rate of the link is increased, so time taken is decreased. Like this, you can keep varying the parameters and observing the results. Students, did you understand that?
Yes, sir.
Yes, sir.
Okay, so that's the one part of observing the results. So there is one more part of observing the results, which is animation. Till now, you saw only the what text kind of results. Now you can see the animation also. For that animation, remember the command to get into that animation is what netanim. Whereas for that, you'll have to go to this netanim folder. Where are you right now? So basically, you went to the NS3 and went to the scratch for creating a program, came back to the NS3 for execution, which is by using /waf. Whereas for executing this netanim, you will have to go to the folder netanim. Where is this netanim? It is in the NS all-in-one with this NS33, right? So now let's see that. Okay. Now, so as I mentioned inside the program, as I mentioned, this is the header file. If you want the animation, then you will be using this netanim module. If you don't want the animation, then definitely you'll not be using this. And animation is all about in a chart where the number of nodes you have to draw them and see the communication, right? So for that purpose, see this is where two nodes you are placing. So you see the position of the node 1, node 0 and position of the node 1 we are setting as some on the x-axis and the y-axis parameters we are setting on the coordinates x and the y coordinates we are setting the xyz x-axis and the y-axis positions. So whereas you can also change the positions also, it's not that constraint. Okay, on the x and the y coordinates you can set the position. Once after the animation is completed, the resultant we are putting into the one of the XML file. I repeat, we are putting the content to the XML file. The name of the XML file can be anything of your wish. Okay, so name you can put any XML file right here. Okay, so now for this purpose, I'll just make the number of packets as 4 so that you can see that multiple results. That's all the thing. I'll make a number of folders, number of packets as 4, and what is the XML file name? It is a 1.xml, right? So now let me save it. Is it saved? Yes, it is saved. Let me go to the terminal. I'll execute once again. Okay, so where we are trying to have a communication between the client and server, and how many packets are being exchanged? It is a 4 packets. Okay, and what was the name of the XML file? For your information, it is 1.xml. Wherever you are, it is NS33. So here itself, you just do ls. When you do the ls, so among the list of files you are available in this NS33, your XML file name should also be there. It is 1.xml. I hope it is visible to you all. It is 1.xml. Once after the XML file is created, then only you can animate. Okay, then only you can animate. For that animation, I hope I told you right now we are in this NS33. We're supposed to go to this NS all-in-one. For that cd double dot. Again, inside this NS all-in-one, see this is what the folder which is netanim, where we need to get into. So from the NS all-in-one, I need to get into the cd netanim 3.108, whatever may be the version, it is a netanim folder you're supposed to get in. And this is where you're supposed to run the command netanim, which is n caps a caps /netanim. So /waf for execution, /waf, where is it? Yeah, dot slash WAP for execution, whereas dot slash netanim for animation. I'll just open. You just type dot slash netanim. So where the network animator will open like this. Now at the left top corner, you can observe, which is there is a option called as open XML trace file. Click on that open XML trace file and select your XML file. What is my XML file? It is one.xml. I'll just select it. So two nodes are placed. So here is a play button. Okay. I'll just play it. See, from the 0 packet will go to the 1. Again, for that, you're getting the response as I have did for 4 packets. So 4 times command go. So this you can observe this clearly. So that's how the simulation or animation is working right here. And even if you want to visualize, okay, if you want to visualize the what we say that statistics, so you can observe, click on stats, so where you can visualize, see node 0, what is the IP address, and what is the MAC address, what is the node 1 IP address, MAC address, what is the port numbers, all that you can visualize. Even the packets, when you click on the packet, see basically this is what happened. So you can observe this is what happened. So command go 0 for the for the first packet, request and response. After, see, this is what the interval of 1 second whatever we have set for every packet intervals, right? Even you can observe the same results you can here also from from node 0 to the node 1, transaction has happened at 2 seconds, again one back to the 0, at what time transaction has happened, like that. So you can also see the results in the animator also, right? So that is what the end of this experiment. Any queries, guys?
No, sir.
Okay, so now, so if you do not have any queries in the sense, then I'll move on to the next experiment. So next